want to talk to you about the difficulties of the integral bolster chef's knife and where you should be at if you had made some mistakes along the way. To begin, obviously when you forge a knife, it's not going to be exact. You should try and get it as straight as you can. But if you don't have something like a forge press and you've got rounded dies on a power hammer, or you're doing this by hand, you're going to run into the fact that things are not completely even and straight the way that you would draw them out on paper. So I'm going to walk you through this as if you had made some of the mistakes that I made along the way. Maybe that's some personal forging issues, and maybe that's some technical issues of not having the right equipment. You pick for yourself. Really, it doesn't matter. I wouldn't come up here and say I'm an expert. I'm figuring this out as best I can without all the instructions along the way. So what you want to think of when you get started on making this knife is the general geometric shape of knives, the way that they are technically supposed to be laid out. And what I mean by that comes down to this little key right here in the center called the ricasso. Now, some people, when they look at the knife, are like, well, where is the ricasso? Is the ricasso the guard? Are those two different things? Yes and no. In an integral bolster knife, technically, and unless I'm incorrect here, they're one and the same in the fact that typically when a knife is held by a chef, there will be a finger well in here, and they will hold up forward on the knife where their finger on their middle finger is in the well, and the rest of the knife is held over the top like this, so they can do more, I don't know, paring, cutting, less hard chopping, and more fine-tuned cuts. If you would like to correct me on any of that, I'm open to that interpretation. But to begin, the ricasso, the bolster, here where traditionally, you'd have like a guard come down on a hunter or a buoy. This area where the guard is at is the center point of the knife. So this ricasso area in here needs to be made exactly correct before you get started with anything else. So I drew a little diagram to show you. I just used a simple golden ratio rule of the 1/3, 2/3, putting this in the center. This also establishes a good weight center point for the middle of the knife. But when you're getting it laid out and you're grinding things, you're going to find out that the knife probably isn't exactly straight. Where on a flat blade that you're forging, you're able to lay it completely down on the anvil. This bolster ricasso area is going to make it a high center point for your knife being able to balance. So you're going to set your knife blade off on this side to try and forge it flat, and then you're going to try and forge your handle area flat, and then you're going to try and look down your center line here and see if you can make it all line up. Now that can be really difficult. I did the best that I could, but as you can see, drawing just a hasty center line mark, I can tell that my handle material is a little light here, and I can tell that my bolster is bigger on this side than it is on this side, and my point isn't exactly where I would like it to be in alignment with all these things. So when you start grinding and grinding out all of the areas where you've got buildup of slag and some infractions in your welds, you got to grind those away to find out exactly what steel you have to work with, and then start working from there. So in this area, this ricasso, depending on what it's going to look like from the crafting standpoint, I'm just using this as an inch square so that you could take either a mill or a face plate on a grinding machine and just go ahead and get this as square as you can get it. Measure it with a micrometer. If you don't have a mill, you're going to measure the distance here and here and here and here, and then swipe it through, and anywhere in the middle that you have issues, you're going to grind down even and flat. Once this is as square as you can get it, then you're going to take the center line and the center line of your point, your knife, and you're going to scribe a line through there, and you're going to try and line your handle up as best you can. But if this is a hidden tang knife, which this will be, it doesn't really matter how thick this is going to be. Obviously you don't want it so paper thin that it's going to shear, but I've got a lot of area to work with in my handle that I don't in other areas. So my focus in my knife is I'm going to have to mill this, knowing that I've got some slag and some other infractions here in the knife, clean and even to a 1-inch square area, And then I should be able to balance my knife off of that completely flat ricasso and scribe my center line along the far back edge of my blade, as well as all the way down on from point to heel on the bevel in the edge of my cutting blade. So think of this like a diamond, as it shapes high in the center near the ricasso down to the point and to the butt of your knife, and then as it comes also in an angled shape from the spine of your knife down to your cutting edge and the heel of the blade.
So obviously I skipped through some of the welding, and I'm just going to show you some of the hammer forging that we're doing and drawing out these layers. But I started with two 4-foot bars of one 1084 and one 15 and 20 piece. I cut it into a stack of 19 and welded it up, drew it out, hammer smacked it, got it to a cut of 4 and the same process into a cut of 3, and that's the 228 layers. I'm cutting in a cross pattern here, almost like a plaid type shape, trying to draw out that pattern for layered Damascus. And then we're starting to really draw out the fine bar of 228 layers here so that I can start shaping it, as you'll see. I've had a few people criticize the fact that these dies are simply rounded dies and there's not a half flat area for work and straightening and things like that. This is an original piece, and what I mean by that is this power hammer was shipped on the Great Northern Railway to Kalispell, Montana in 1915. Based on the microfilm and records at the Historical Society that I've gone through, this is the oldest piece of industrial shop equipment that came to the Flathead Valley at the time. And the model number on this little giant is actually 174, meaning that it was some of the oldest and most original 100-pound models that I've even heard of. So using this in its original capacity, minus obviously the electric motor, is a piece of historical context that I do try and add into my work. So forgive me for not having it in a really updated state, but I love the history of this hammer. Now, one thing you'll see is a lot of hammering and straightening and a short couple of clips here. I could not film every time I took my piece over to the anvil in between my power hammer motions, but it was very necessary to ensure that this was straight. Obviously here I'm just cleaning the slag off the blade and doing a test etch to see what the pattern's gonna look like. The more you do with a angle grinder to remove some of the scale on your work is really gonna help you save your belts in your process. Then what I'm doing is I'm moving over to checking this with a straight edge, doing some just basic measurements before I really even shot the start of this video, just the talking through to see where I was at. And then obviously I'm moving over to my mill, and I'm working to start cutting in the ricasso clean and square so that I can use that as the center point, or quote unquote the key for the design of the rest of the knife. And I can't speak to this enough. I must have gone over to my granite slab area and used my scribe to check my center lines and the shape of this knife 100 times over. It kept coming back and forth into what I considered good or straight or in position, and it's really difficult to even explain to somebody who's never tried to do this before what it's like to get a straight edge through a knife with a high point that's already built into the center of it. It's almost counterintuitive based on my experience. So if you ever make an integral knife, I have an incredible amount of respect for you on how difficult it is to get everything lined up, even by eye and by measurement, to work for you in the process. I wanted to leave a lot of room for error, so I left the original thickness of the tang and the spine of the knife to well over 100 thousandths, probably call it 150 thousandths. And then what you'll see is I do that also in the integral bolster area or the ricasso. I'm leaving more than an inch, probably 1.5 inches or 1.25 inches when I begin my grinding, because I know in between all of the adjustments that I'm going to make, including the heat treatment, getting this set up is going to need a lot of room for error once heat treatment has taken place in case there's a warp. Making sure that while I'm making some artistic changes, that I'm doing that in such a way that I'm not cutting into where I want my ricasso to be. Kyle Royer has explained that in a lot of his videos for knives. When you're getting started working through your knife, you want to leave some room for error because you most likely will make some accidental mistakes over where your lines are, and you don't want that to be the finished product. You want that to be a very careful, planned area of work in the last few steps of your knife that you're doing with a higher grit belt. So coming up to certain lines looks almost perfect, if not perfect. Now, after my bolster, I wanted to do some rounded bevels that come right off the ends of that integral bolster down to where the blade starts. And I actually did a 2-tier area, and using this platen set up like it was so that I could grind that in was awesome. I mean, I was just shocked how well it kept things in position so that I could keep these lines kind of neat and square and make sure that I wasn't cutting into areas of the knife that I did not want it to take place. You'd be surprised how hard it is to get this area of your knife lined up so that you don't have to make large changes later. I want to talk about this step right here. It's very important for you. If you have an integral bolster, you have to make sure that where this area fits up to your next pieces of where your handle material is going to be on your tang, if you do not get it completely square and even at this point in the process, once you harden that steel, you cannot file it, you cannot use an actual jig and in conjunction with a 2x72 grinder, because even if it is carbide steel, as hard as your blade will then be, the belts that you're going to have to use to cut your steel on your knife will be hard enough to cut into the carbide jig itself, and that's not going to be good because it'll always set your jig off for the rest of time. So if you can, make sure that that area of your knife behind where the integral bolster is, where it's going to connect to your whether you're going to have additional guard material or if you're going to have like a brass fittings that are kind of artistic that'll go in there to make like a hidden tang, whatever you're going to do, make sure that it is even, because if it's not, it is going to be such a problem. And it was for me on my knife during the glue up. I had to do a few different things and it just did not come out perfect. There's a visible line now on that knife between the guard material and that integral bolster, and it's so sad because the rest of this knife was in almost immaculate shape. So that's one of the big areas that I was disappointed on with the process of doing this knife. Now, all that being said, you can see this Sand Shark here by Tyrell Knifeworks. I used it on my blade area, I used it on my tang, I used it on parts of the knife that you would not expect. Anywhere where there's grooves or lumps or areas that you have some small grind lines, using this sand shark was key to be able to take those out by hand. It was just awesome. I was very happy to have purchased this at a very reasonable price. Most of the machines in the shop are expensive. Your 2x72 grinder, even if you get a cheap one, is going to be probably a minimum of $1,500 to $2,000 without belts or extra attachments or tools. If you make one yourself, maybe you can get away at about $1,000. The cost is in the motor. So having this tool that Tyrell sells for less than $1,000, I think I got one of the first models, so I was into it for like $650 plus shipping. I would have paid more for this machine. It's great. There's a couple of things that I might add some things to, like some areas where you can sit your wrists on so your hands aren't bouncing around as much. He's got a couple of tools that he's put out that come with it now that are great, but I think those areas where you can see the bolt holes in it, if you would replace those flat angle iron pieces with a tougher iron and their connections to the machine with a stronger steel, and then made those into like a leather seat where you can rest your hands, but there's still an area for the machine to push you back so you have forward pressure. I think that would be key to a personal improvement. So I'm going to try and do that in another video, but this is the coffee etching. This is basically me showing myself, okay, the pattern's coming together. It's going to polish out nice. I don't have eroded areas or major infractions in my steel. And even though I make some more adjustments to thin the blade out and shape it more like a chef's knife, then I'm still really impressed with the way this comes out. Let's talk hand stamping. Okay, this stamp is from Everstamp, and they're a company out on the East Coast, like everything in blacksmithing seems to be. But you'll see me stamp it right there. The angle at which my dad was holding the knife, I think, accidentally bent the tang. Now, what I was doing was I was thermocycling my steel. I was running it out of its disturbed state up through its cycles. So I started at like 1,000, and then I went to 1,200 and 1,300, and I think I stamped at 1,200, and then I went back up to 1,300, and then down to 600, and then back up to 1,400, down to 600, and back up to, I think I quenched this at 1,525. But when I quenched it, you probably can't hear me in the background because I'm talking over it, but I was like, this is the worst quench I think I've ever had in my life, and this is the worst warp that I've personally seen. It was warped in like 3 areas, and that could have been from grinding or whatever mistakes, but I didn't have time to show it on camera, but I had to put this knife back to the anvil. I heated it up in that quenching oven to like 1,300, and I had to very lightly hand hammer some of the areas out to try and get it straight. And that was probably the most nerve-wracking thing I've ever done in my life, was trying to straighten this knife out after the quench. So just keep in mind, I think as a sense of positive message for those new knife makers, the likelihood of you probably having warps in your blades are high, and if you put a lot of time into this, take a deep breath, just start evaluating your next steps and start doing something. Not out of anger, maybe take a day off to sit with you, but start focusing on how to fix it, and then fix it, and just methodically work through patient, consistent steps to get things done. So what you've seen me do here is just drill out my holes for the guard material, the handle material, and drill out the handle material itself. I had a Kume Gane that I made out of quarters. Tyrell Knifeworks does some great videos on that. And then it was an oak burl stabilized in epoxy, and it was colored blue, and it was really pretty. But getting probably that and the spacer material, I used a black spacer material, and all of my pins fit it up. It took me, I mean, probably 2 hours to just drill holes, get my material set up, get everything checked and verified and balanced, dropping pieces everywhere to fit together, and then the glue up. So this is removing the glue up. We'll finish the knife from here. In order to get the right shape to the Kumegane, I used a couple of aluminum blocks on my platen that I clamped in place on both sides, measuring the angle from the front of the platen so that I could get the grinds consistent and the shape consistent the way I wanted it. And then I start fixing the secondary bevel for the chef's knife, doing a little combination of the Johnny Appleseed grind and maybe an S grind so that the knife overall would have the ability to cut and separate itself from the material it's cutting so you don't get like apples and stuff that stick to the edge. But whether or not you're a newbie knowing this or an expert knife maker, you may or may not have heard that term before. And then it's just hand polishing and hand sanding and Tyrell Knifework Sand Shark and getting it all ready with a little bit of acid etch. And finally, using my Wicked Edge to sharpen the final cutting edge, and it was ready to go. Now this knife was a gift from my brother-in-law for his wedding. Obviously, congratulations, guys. I'm very proud of you. I was happy to try and put something together that looks nice, and I got this nice magnetic cutting board and knife holder on Amazon. I think it's a great placement for people if they want to use a knife in the future, and this is them cutting their cake at the wedding. Thanks for watching.